Hi, my name is Sam Maltese. Today we're going to talk about wiring in residential homes, basically wooden structures. In most wooden structures in residential, you use a cable called MMD90, non-metallic sheet cable. It's also known as Romex cable. Most of these cables go into outlet boxes of different sizes and at different heights. There is nothing in the code book that says what height a box needs to be mounted at, but in general, we mount our switches for our lights at 52 inches, our counters, plugs for the kitchen at 42, and usually in our washrooms we mount our GFI plugs at 45. Our plugs along the wall are usually mounted around 16 inches to the bottom of the box, could be 14. Like I said, there is no specific rule that requires a height. Whatever is more comfortable for the customer or the electrician that is installing the outlets. So once again, in this case we've used the bottom of the box around 16 inches. As I mentioned before, our counters would be at 42, our washrooms would be at 45, and our switches would be at 52. Some of the most common materials used in residential wiring in homes are on this table, and we're going to discuss them very general so that we can know what kind of material is needed, what kind of devices we'll be using, and how to install them. Here you see the 5 most common cables used in residential wiring. You have the 14-2 non-metallic sheet cable, or Romex, 12-2 cable used for baseboard heaters. This is the most common used for lights and plugs and everything else. You have 14-3 that may be used for split plugs in the kitchen or for 3-way switches. You have your 10-3 that is used for your dryer, and you have a 3-conductor number 8 wire that is used for your stove. This is designed to handle your 40 amps, designed to handle 30 amps. This can handle 15 amps, 20 amps, and 15 amps. On most of these cables, on the outside sheath, you will find markings indicating the size of wire and the conductors. You'll notice on the stove cable, it says that it is an 8-gauge wire and 3 conductors, 3C. So 8 American wire gauge, 3 conductor. This will be repeated for your 14-2, your 10-3, and your 14-3. They will all have markings on it. Here are some of the devices you'll be installing in your outlet boxes. You have a single pole switch, you have a 3-way switch, a regular U-ground receptacle, a GFI plug, a stove receptacle, and a dryer receptacle. Your single pole switches, such as this one, has 2 screws on the side. They're both the same color. There's no distinction between a silver or brass as in the other devices. But in general, the hot wire is connected on the top screw, and the wire going back to the light is connected on the bottom. In the 3-way switch, you'll notice that there is screws on both sides. There's 2 brass screws on the top and a black screw at the bottom. The black screw indicates the common point of the 3-way switch. And the 2 travelers in a 14-3 wire go on the brass screws. When dealing with the receptacles, you have a green screw for the ground. The silver screws on this side indicate the neutral, and if you flip the plug over, you'll see that these screws are brass. That indicates that is where the hot wire goes, or the black. So the neutral and the ground are on the same side. You'll also notice if you look at the front that one of these slots is longer than the other. The short slot represents the hot wire, where the brass is. Your GFI is the same as the plug. It has 2 different colors on both sides for hot and for neutral, with the green at the top. Your stove plug has 3 prongs, the U being the ground, right below would be the neutral, and these would be the 2 hots. If you turn it around, they are usually marked on here what color they take. This takes the ground, a hot, and the neutral. It says white there, and you'll see it says X and Y over here. This plug is also known in the code book as a 14-50R. So a 14-50R is the name for a stove receptacle. The other receptacle very similar to that is the dryer receptacle. It is known as a 14-30R. The 30 represents 30 amps, just like the 50 represents 50 amps on the stove. The only difference between the two is you'll notice that the configuration here is different from the stove. The stove has all straight slots. The dryer has this little L. So that's a good way of knowing that you're dealing with a dryer receptacle. Just remember that L represents laundry. The back is the same as the stove. It has 4 screws. One takes the ground, one takes the neutral, and the red and black are the hots. There are 4 types of boxes I want to talk about today. The most common is known as the 1104. It is 2 inches wide, 3 inches long, and this one here is 2.5 inch deep. That's a standard box that's used for most switches and plugs. You'll also notice at the back there are screws for fastening your ground wires. There's clamps at the top and bottom, so you could bring your cables in to the top. And on the side here, some of them will have these indicators indicating that they line up with the stud, so that when we put the drywall there, the box isn't recessed. And we'll show that later on. Same type of box, but in this case, it's just a little deeper. The reason it's deeper is so that if you're using it for a GFI plug, there is more room at the back for wires. So when installing GFI plug, we usually use a box that is 3 inches deep. Another box that's used is the 14 by 11/16. That is used for your dryer and stove plugs. Much bigger box for a much bigger receptacle. Another box that's used quite often is these new foam boxes that are made out of plastic. These are used on the exterior walls of a house that create a vapor barrier, and no moisture gets in or no cold air gets in. If you look around, you'll see it's got foam on the top, so when you pierce it with a cable, it kind of seals around it and prevents any moisture from coming in, and you get no drafts in your home. The 3 most common staples used for Romex wire are the S1, S2, and S4. S1 is designed to handle 14.2 and 12.2 cable. The S2 is designed for 14.3, and the S4 is designed for your stove cable. So depending on the size of the cable, you use the correct staple. As you can see, that's designed for your stove cable, and this is designed for your 12.2 or 14.2, and your S2 will be designed for your 14.3 cable. Each cable has a different height, so it stops at the wood and giving it enough space in between so the cable doesn't get crushed. The whole intention of the staple is just to keep the cable in place and not to fasten it too tight, but just prevent it from moving around. Another type of connector that's used are these plastic connectors that take cables by just pushing them in, and they pass through and lock in place, and they do not slip back. When using electrical devices or anything to do with electricity, most products will come with a CSA approval. Look for this symbol. That means it's been approved to be used in Canada. This is a box for staples number 1, and if you look at it very closely, it says that it's designed for one single cable of 14.2 or one single cable of 12.2. If you move over to the next box and we were to zoom in a bit, you'll notice that these cables, this staple can handle a 14.2, a 12.2, a 14.3, a 12.3, a 12.2, and a 10.3. So obviously you can handle many more cables that are thicker. It also says that you could put two cables together of 14.2 and two cables together of 12.2. So you can basically stack them one on top of the other and still use this cable. If you move over to the connector says, the gray connector we were showing, says you can only put one cable in of 14.2 or one cable of 14.3 or one cable of 12.2 or 10.2. Not two cables at the same time. So this cable, the conductor, is only designed to take one cable at a time. There are manufacturers that design connectors that will take two cables. But you need to have this cover or this information to prove to the electrical inspector that your equipment can take two cables. If you have this information, then it meets code. Now that we know some of the materials and devices and boxes and connectors and staples that we're going to be using, we can now move on to the proper way of installing the cables into the boxes. In general, most boxes require to have at least 6 inches of wires after they've been installed in the box. That is due to Canadian code. So how much of this wire outside sheet do I need to strip so that when I'm done I have 6 inches of wire? I usually use the 10-inch rule, and I can usually line it up between here and my elbow, roughly is 10 inches, or you can take your hand with the thumb out and the fist, and that should be about 10 inches. So roughly that much is about 10 inches for me. It works good for me. If you want to measure measuring tape, the more experience you have, you'll learn to quickly decide what is 10 inches. So you take your cable and you take your knife. If you're using a 14.2, you can run it down the middle to strip the cable along the copper, and take the outer sheet cut it off. To be careful not to nick the wires. Take the outer sheath off so that you have the black and white and ground left over, and then you're going to install it into the box. The top of each of the boxes are little holes that you can take out, so you can put it into the box and then make your connections. We'll move in closer so you can see exactly how that's done. Okay, we're zoomed into the box, so I'm going to take my cable now and going to put it into the back of one of the holes and bring the cable forward. I put a little bit of curve to it so when I push it in, it comes forward and doesn't get caught in the back. And I want the cable to the point where I can just see the white in the back. All right, you want to see the sheath on it, and then you tighten the clamp on the screws. Not too tight, just snug enough so that the wire, when you tug on it, doesn't come loose. It still stays in the box. So that's what we're looking for, is for the cable not to move or be able to pull it out. What I didn't do is I take my black wire, move that up, and my white, leaving me only my copper. In any box, you should be grounding the box to the ground conductor, whether it be a switch, a plug, or the stove or dryer. They all need to be grounded. So you're going to take this copper wire and you're going to wrap it around the screw in the back in a clockwise direction. You always do it clockwise, so when you tighten the screw, it actually pulls in the copper. So as you can see, I wrapped it around clockwise, and now I'm going to tighten this screw so that the copper now is bonded to the box. You'll notice now that my copper is bounded, and if I take my black and white wires down now, you will notice that they are a little shorter. The copper wire is a little shorter because I wrapped it around the screw. So what I usually do is I like to trim them all the same length so that when making the connection to your plug, they all look and connect very evenly. So I'll trim those two. They're all the same. And now if I were to measure from the edge of the box to the end of my cables, I should have 6 inches. Okay, we reposition the camera now so I can get a better view of the length of the cable. Remember that the code requires 6 inches from the edge of the box. There will be drywall here, so all you're going to see is the edge of this box at the drywall. So we take a tape measure and we put it there. You'll notice that we are roughly at 6 inches, and that's the minimum amount of wire required as per code. So we'll turn it that way. You'll see the 6, that we have 6 inches minimum. I could have 8, I could have 9, but I have to have 6. That is the minimum code requirement. The next step would be to either hook up a plug if we were down towards the floor, or in this case we would hook up a switch. Either one, the plug is always going to need a ground, so you need to have this ground wire out. Most switches do not have a ground, so if you want, you can tuck this ground wire nicely back towards the back so it doesn't interfere, it does not touch on some of the black wires. In general, when I'm dealing with switches, I like to cut the ground wire back at the screw and leave nothing coming forward. And I just like to leave the ground with my receptacles. We're now ready to hook up our plug or our switch. So I usually like to strip about 1 inch of the insulator off the white and 1 inch of the black insulator. This allows me to take my strippers and make a loop, such as that. Make a loop. Make a loop. And once again, when putting these wires on the screws, you should always be wrapping the conductor in a clockwise rotation, so when you tighten the screw, it sucks the wire in. Okay? If you're using a switch, the hot wire would go on the top and the wire going to the light would go on the bottom. So we're going to hook up the plug in this case. The black wire will go on the brass screw. Once again, in a clockwise direction, wrap the wire around and tighten up the screw. The screws on plugs and receptacles, switches, is a green Robbie. Wrap the white wire on the silver screw, followed by the ground that's on the same side as the neutral. So there should be no wires sticking out. Everything should be underneath the screws, and you're ready to install the plug. Push the wires in. There is no code that says which way the plug should go, whether it be with the ground up or down. I personally like to have the ground on the top, but most people are familiar looking at it with the ground on the bottom. The screws that come with the plugs are 632s. They go into the holes here. And if we had drywall here, you would be fastening the screws in those holes. And you would tighten that to a point where it stops on the drywall. We have no drywall here, just as a demonstration. But this could be a switch or could be a plug. The same principle applies to all devices. So for today, that's the general rules for putting a 14-2 wire into a box. The same rule applies for 14-3, for 12-2, or stove wire. You always need that 6 inches coming out from the box.